Alright, so this will be my third example on the washer method. So we're revolving a graph about an axis and we're going to find the volume. So the volume is pi times the integral a to b of big R of x squared minus little r of x squared. And big R is the upper or outer radius and little r is the inner or lower radius. Okay, and once you find the big R and the little r, you just plug it in here and integrate. Alright, so let's take a look at the third example. It says find the volume of the solid form by revolving the region bounded by the graphs of y equal x squared plus 1, y equals 0, x equals 0, and x equal 1 about the y-axis. Alright, so first thing we need to do is draw a graph. So let's see. Alright, so if we graph y equals 0, that's just the x-axis here. We draw the line x equals 0, that's the y-axis here, and then x equal 1. Now we'll put it out here, give ourselves some room. So there's the line y equals 1. Now let's graph y equals x squared plus 1. Alright, so that's a parabola that opens upward. The vertex is going to be at 0, 1. So it's going to look something like, this. Okay. Alright, now we're revolving around this axis here, the y-axis. Okay, so let's look at this for a minute. Okay, so we're going around the y-axis, so we know our rectangles, we draw them perpendicular to the axis that we're revolving them around. Okay, now if you notice here, well, the big R, the outer radius, well, that's easy. That's this point 1. Okay, this is this distance from here to here. That's big R. Okay, that's the outer radius. But if you notice little r, the inner radius, from here to here, little r, okay, is 0. Okay, remember here's the inner radius, and this radius here is on the y-axis, so little r would be 0. But once we get here, little r changes. So what we're going to need to do is split this up into two separate regions. Okay, and so we'll need to draw us another rectangle. Okay, and this distance from here to here, that's going to be little r. But remember, in both regions, in this region and this region, big R is the same. See, that's the same. Alright, so the thickness of this rectangle, that would be delta y, and this would be delta y. Okay, so we're integrating with respect to y. So what we're going to have to do is take y equals x squared plus 1. We're going to have to solve this thing for x because we need everything in terms of y. So that's going to tell us that x is equal to plus or minus the square root of said y and wrote x. It's plus or minus the square root of y minus 1. Okay, So, so that tells us that x is equal to the square root, well, I'm sorry, not x, but little r, this distance from here to here. See, this in terms of y is x equal plus or minus the square root of y minus 1. So this distance from here to here would be positive square root of y minus 1. And we know it's positive because we're on this side of the y-axis. See, if we use the negative and say we put in, I don't know, 2 for y, then x would be negative 1. See, it would be over here. So that's how we know that it's the positive. Alright, so let's just write out what r, and in this case, instead of r of x, it's actually r of y, because we're in terms of y. That's equal to, okay, it's equal to 0 when y is between 0 and 1. See, here's y equals 0, here's y equal 1. And when y is between 0 and 1, little r is 0. And when y is between 1 and some other number, well, what would this, see, we need this point here. We need that value. Okay, well, let's see. We know this is when x is 1, so if we plug 1 in here, that's 1 squared is 1 plus 1 is 2, so that's the point 1, 2. And so we know that this y value here would be 2. So between 1 and 2, little r is the square root of y minus 1. Okay? And then, once again, big R of y, the whole from 0 to 2, big R is just 1. Alright, so now we have to set up our integral from 0 to 1, and we have to set our integral up from 1 to 2. Okay, so let's look at that. Alright, so from when y is between 0 and 1, okay, big R of y squared minus little r of y squared is equal to 1 squared, see I plug this in, minus, and little r of y, okay, remember we're from 0 to 1, little r of y is 0. So that's 0 squared, and so that just equals 1. And then when y is between 1 and 2, we have big R of y squared minus little r of y squared. And so big R of y from 1 to 2, that's still 1, minus little r of y squared. And little r of y, that's this distance from here to here, and between 1 and 2, that's square root of y minus 1 squared. And so that's 1 minus y minus 1. So that's going to give us y minus y plus 1, which is 2 minus y. Okay. Alright, so now let's set up our integrals. So I know that the volume is pi times the integral, and first I'm going to go from 0 to 1. Okay, and well, that's just 1 dy plus, Okay, because see, this right here, this and this is what I have to plug in for r of y squared minus big R of y squared minus little r of y squared. And so that's plus the integral from 1 to 2, okay, of this 2 minus y squared dy. So nope, I'm sorry, I left the pi off here. Okay, so that's going to be pi, and then when I integrate that, well, that's just y, and I'm going from 0 to 1 plus pi, and that's going to be, let's see, 2y minus 1/2 y squared, and that's going from 1 to 2. Alright, so now let's plug everything in. So that's going to be v equals pi times 1 minus 0, okay, when I evaluate this, plus pi times 2 times 2 minus 1/2 times 2 squared minus, and then I plug the 1 in, 2 times y minus 1/2 times 1 squared. And that is going to give me, when I evaluate all that, that is going to give me 3 pi over 2. And there's my answer. Alright, so I hope this video helped. Hope you'll check out my other videos. I've got some more of the washer method. Alright, thanks.